Algebra 1, Lesson 73, we are looking at solving compound inequalities. This will be a pretty quick video on this. So compound inequalities are two inequalities that are combined with and or. A specific type is a conjunction, which uses the word and we also have a disjunction that uses the word or. So these compound inequalities, you might see them like this: x is less than -2 or x is greater than 4. That's technically a disjunction, which is a type of compound inequality. Another type is a conjunction that uses the word and. So x is greater than 3 and x is less than 5. Meaning this is kind of related to number sets where we said a solution to this has to satisfy both of these. So a number that would be a solution to these inequalities would have to be greater than 3 and less than 5. So looking at a specific example, if we had something like x is greater than -3 and x is less than 5, we can rewrite it as -3 is less than x is less than 5. That's because we can switch around this first one to say that we have -3 is less than x. We just switched everything around. And then we can combine that, since we're talking about the same x, really we can combine it with my x is less than 5 by just smushing them together. So we have -3 is less than x, which is less than 5. Well, on a graph, just a very quick version of this, we would say we have an open dot on -3 going to the right. That satisfies the first inequality. And an open dot going to the left. Well, really what we have is this connection between these two, saying that anything in this range here would be a solution to the inequality. Okay, and that's probably the best way to go about graphing these, is doing each side of this. So splitting it up to say we have an x greater than -3 and x that's less than 5. Let's try again. All real numbers that are greater than 1 and less than 4. So our original inequalities are x needs to be greater than 1 and x needs to be less than 4. So combined, we switch this around to say 1 is greater than, not greater than, 1 is less than x, which is less than 4. So from 1 to 4, we have our solutions. Okay, the winds range from 75 miles per hour to 200. Well, that means I have an x that is greater than or equal to 75, but an x that is less than or equal to 20 or 200. We can combine this to say 75 is less than or equal to x, which is less than or equal to 200. And I include 75 and 200 because they can have wind speeds that are that high. Okay, those exact wind speeds are possible. Now let's look at a word problem that fits this type of these compound inequalities. So a cell phone contract includes a monthly usage fee of $10 plus an additional 10 cents per minute. We'll use x as our minutes of talk time. Suppose that the monthly cell phone bill is between $30 and $40, meaning that this amount, $10 plus 0.1x, has to be greater than or equal to 30, but it also has to be less than or equal to 40. Now I can solve each of these inequalities to then combine them for how many minutes of talk time am I allowed to have between $30 and $40. So this first one I'm going to solve over here. I'm going to add 10 to each side and get 0.1x is greater than or equal to 20. And then I'm going to divide by 0.1 or multiply by 10, get x is greater than or equal to 200. And same idea with the second one, but we get x is less than or equal to 300. So we can combine them to say my talk time is between 200 included and 300. And we can put that on a graph. All right, now disjunctions on the other side of this, still compound inequalities, but these are two separate inequalities. If we're thinking about number sets, this is like a union because a solution can be in either of the sets, either of the inequalities. They just have to satisfy at least once. So we have all real numbers that are greater than 9 or less than 3, like this. Now how we graph it, because we can't combine them, so we actually just leave it as is. But we say we have a 3 down here, open dot going to the left, and we have 9 up here, open dot going to the right. So we would have these inequalities, and we can see that they are a disjunction. Okay, there is no point that they intersect or overlap, okay, like our conjunctions do. This is a union where I could have a number that is less than 3, or I could have a number that's greater than 9, and it would satisfy this compound inequality. All right, so just a couple more examples here. All numbers no more than 7 and no less than 11. Okay, and then all real numbers no more than 3 or no less than 8. Both of these are disjunctions that we would say x needs to be, okay, no more than 7. So it can't be more than 7, meaning that it can be less than or equal to 7. And then x needs to be no less than 11. So it can't be less than 11. So it needs to be greater than or equal to 11. And I can put this on my graph, close dot, going to the right, sorry about that. Let me erase some of those. And then for the 7, same idea, but going to the left. All right. And for the one on the bottom, we're going to have the same idea, okay? But instead, no more than 3 and no less than 8. All right. So now we need to make sure we can solve these disjunctions as well. So just like we did with the word problem, we need to get x by itself in order to be able to graph these. So in this first case, I would need to add 3 to each side so I can get x by itself. We have x is less than -2. Or, let's see, we divide by -2 here, but remember if we're dividing by a negative number, I need to flip the sign, and we have x is greater than 3. So this truly is a disjunction, with our -2 having an open dot going to the left, and we have 3 open dot going to the right. So this is a disjunction. And same with the bottom one. Okay, subtract 6, divide by -3, make sure to switch the sign. And last example here, write a compound inequality from the graph. Well, I would start by writing each individual part. So first we have x that's greater than -1, and because they combine, we have x is less than or equal to 5. So I would say this combined would be a -1 is less than x, which is less than or equal to 5. You'll always notice that the smallest number is on the left of your inequality, highest number on the right, with all of these either less than or equal to signs. And you can try this bottom one on your own. This is a disjunction, so think about using the word or. Well, I hope this is helpful for your homework and for studying.